are here for the area of flight lesson. This is to better prepare you for your workplace later on when you're going to handle the real flight. Okay, my name is Sash. I'm the trainer for the day. There's basically only two objectives that we're going to learn today, but please pay attention to everything that's going on. Okay? Firstly, safety. Please, if there's any emergency, there's a door, only take yourselves down. Do not take your laptop, which is at the back, your other valuable items that you think that's valuable, which is not actually, except your handphone and anything else that is nearby that you think is valuable, is accessible to you, yes, if not, don't. Do not take the lift in case there's a fire. Gather at the common area, down, then there'll be one person doing a head count. Okay? So far so clear? Next, ground rules. Number one, please silence all your devices. Okay, I do not want to hear any ringing. If I do, it's mine. It means definitely I'll return it back to you after the end of the lesson. Okay. Any phone calls, if it's urgent, yes, please, you can attend outside. Which means you will actually be missing something that you're learning here. So unless it's really urgent, please do not answer the phone. And raise your hands to sound your opinions or you ask your questions. If I'm going too fast, let me know. If I'm going too slow, please also let me know. Okay. Then next, introduction. I'm Sash for the day. I'm 30. My hobby is to fly. Okay, as you know, I like to fly. So as you go on, can we have one person to each of you all to introduce yourself, starting from you?
My name is Eric. I'm 54, and coincidentally, I like to fly too, but I don't physically fly. I collect airplane models.
Okay, that's nice.
I'm Elaine, 50, and I like Muay Thai boxing.
Oh, nice.
I'm Eddie. My age is 45. I like horse riding.
Horse riding. Okay.
My name is Ili. My actual age is 27, not 16 that I tell everybody. And I actually also love to fly, but I can't because I'm too short.
Oh, have you ever attended?
I wanted to, but they say I don't meet the height requirement.
Oh, right. Which airline?
No, I like the youth flying club.
Do you find club, right? Okay, yeah. So now, before we actually go into the lesson proper, can I know something that hits your mind that the moment I say flight or airport, shoot, ID. First thing.
Travel.
Travel, yes. You like to travel?
Yes,
Where to?
everywhere.
Okay, not something that we're going to cover today. Next,
Fly.
flight,
Take off.
take off. Okay, something that we might touch on today. Okay, next.
Flight meals.
Okay. Also not something we are going to touch on today.
And the Concorde, which I think most of us will not be able to touch on at all. in our lifetime.
Okay, Concorde is a totally different topic. Okay, you have to understand a lot of what is going to happen today. These are the basics before we can even touch on Concorde. Okay. As we go along, you all will understand what is Concorde all about. Okay, clear so far? Contents. All of my contents are important, but however, I'm only going to be testing you later on two important contents. Why? It's because the rest of them are only needed for the next part of the lesson. Okay, please pay attention. Any questions, please raise your hand to ask. We're going to be covering the forces acting on a plane, Bernoulli's principle, which was the founder of the lift theory, which we will be covering later, shape of an aerofoil, how the shapes actually influence the lift, angle of attack installed. This part you will know later on. Learning outcomes, describe what are the four forces, and how lift is being produced. That's it. The stall will be tested on the next part, so please pay attention. Even though it's not being tested here, it will definitely be tested later on. Okay, clear so far? Yeah? You two are okay?
Okay.
You okay? Yeah?
Yes, sir.
Eric, are you okay? Yeah? So, the four forces. Anyone knows what they are?
Trust.
Okay.
Drag.
Nope. Okay. I'll cover them as we go along. Okay, what do we mean by thrust, drag, weight, and lift? For this, before I carry on, I actually need you all to do a small activity on it. Okay, a small discussion on what is thrust, drag, lift and weight. So we have group 1 and group 2 here. Please come forward and write down on the board. I think for y'all can just use the whiteboard.
What lift and ours is what
Lift
lift
and
and
weight.
weight.
Okay. Yes. Okay. Nice one. Hmm. Doing good, doing good.
Then you draw.
Okay. One more minute.
I want to draw plain. I don't know. They draw it like this.
One more minute.
Oh, they got picture.
Okay, just hold on a minute. You're done? Okay. So let's move on over here. Please gather around. Somebody.
Lift and weight. Okay, to overcome the weight, so the playing with weight. So the lift must be greater than the weight.
In order for the plane to fly.
Right.
Okay.
I think.
Okay. Okay. Weight of plate. What do you mean by weight of plate?
It's the load.
Yes. What's the word again?
Load.
Yes. Correct. Yes. It's the load that we are talking about here. Okay. The entire load. We call it payload. Okay. You will learn all this later on, but these are key terms that you need to learn. Clear so far? Okay. The relationship is lift generated must be more than weight in order for the flight to take off. What if the lift is equal to the weight? What do you think will happen? Will it take off?
No, it won't take off.
Okay, we will learn about that later on. Let's move on.
Okay, so thrust is actually produced by the engine. This is air going into the engine. It's a jet engine, by the way, not a propeller type, as you
We
can
can
see.
go. Yeah.
And so this is the air. You can see a lot more lines coming out. So that means here is where the thrust is, right, from the engine. Right?
Drag, I guess, is the resisting force.
Okay, and relationship.
In order for the plane to fly.
Yeah, in order for the plane to take off, the thrust must be greater than the drag. The drag, which is the airplane itself, the frame,
Yes.
what's it called? Then the
Okay, not so much of the plane itself, but it's a force resulting from that. Okay? Are you all clear? Okay,
Yes.
take a seat first, then I can explain the. Okay, like this, the thrust, like what you drew here, right? It's just the engine that is going to produce the thrust. But we are not going so much into. Yes? Is there a problem?
No, I just cannot see.
It's okay, you can take a seat first. I'll give you a break in about 20 minutes. You can take a seat first. Thank you. Yeah? You okay? Carry on. Yeah. Okay, so back to topic. Forces acting on a plane. There are 4 forces acting on a plane at all time. Lift, weight, thrust, drag. Lift is what is being produced due to the thrust, like what he drew here. Okay, so because of when you have enough thrust, you get enough lift. Next, it must be at equilibrium at all time, So when the forces are net, this is when the flight is level, straight and level. Meaning, if they are not level, what will happen? Meaning the flight is either going down, up, left, right. Okay? Means it's not level flight. Clear so far? So let's go into Bernoulli's principle. Before we go into Bernoulli's principle, can I know anybody in your house ever tried playing with a pipe? When you close the exit of a pipe, when you are trying to plant your water and you close the exit of the pipe, what do you think will happen?
Water flow faster.
Water flow faster.
Pressure increase.
Again, what's the word?
Pressure increase.
Yes.
Well, the pressure becomes higher because of the smaller area.
Yes, okay. So because of the smaller area, the pressure becomes faster. So it grows faster, right? Okay, same thing. It's the same concept that we are going to apply here. How this works, you can take this as a pipe or as a wind pipe or even a water pipe. What's going to happen is the same amount of air. So in this case, water. It's the same amount of water that what Bernoulli is saying is that when you put the same amount of water through this area of pipe and it's suddenly converging into this area of pipe, what's going to happen? There's a sudden reduction in area. So which means there's an increase in pressure. Sorry, decrease in pressure and there's an increase in velocity. So it goes faster. Okay? Same thing that we are going to apply in an aerofoil. What's going to happen is that, as you can see here, is in the lower surface, this is the streamlines of the wind particles that's flying. Okay? As it flies, the top surface has a longer distance to travel for the same wind particle that is being now flown at the bottom. So what's going to happen is that this area at the bottom is going slower, so the pressure is lower. Sorry, higher. Okay, it's going slower, so there's a higher pressure. Here, higher velocity, so it's lower pressure because here there is more area to be covered, so your pressure will drop. Okay, so because of the potential difference in pressure between the two surfaces, it will cause you lift. Clear so far? Yeah? This is how it's going to look like. Here, the air is lower because the area is bigger. Here, area here is smaller. Here the area is bigger. So the air, the same amount of air has to travel faster. So the pressure is lower. Clear so far? Okay, so we carry on. So that is the principle of lift. Because of the potential difference in the two surfaces, top and bottom, the lifting effect is being produced. Clear so far? Okay, now we can look at angle of attack. Angle of attack and this word stall here, it is not going to be tested for today, or I'm not going to test your understanding today, but you will need this understanding for your further lessons. It's okay so far? Okay, but please do pay attention because when you come back from the break, we are not going to spend too much time on this. Okay? What do we mean by angle of attack? Anybody see the difference between this image and this image?
The difference in the angle.
Exactly, that's the word angle, yes. It's the relative angle here and here. So as you can see in this graph, until this particular point is a linear graph, means it's a straight line. As we keep increasing the angle of attack, the lift produced is also higher. Okay? But at this particular point, it drops. There's a sudden drop. Okay? Are you clear? Is it okay? So stall is when there is a separation of airflow. Do you understand? Yeah? Okay. It's because when there's a separation of airflow from the wing, stall occurs. Anybody ever drove a car? How many of you drive?
Yeah, I do.
How does
I drive.
stalling feel?
That's right.
How does when your engine going to stop, how does it feel? Vibrate a bit, yes. Okay, it's the same thing, just that now it's going to be more scarier because it's going to happen in air. Yeah? Okay. And that is because there is no more reaction between the top surface, between the wing and the surrounding. In this case, surrounding, we are referring to the air around. Okay? Because of that, there is a loss of reaction between the object and the surrounding, there is a loss. So because of that, stall occurs. Clear so far? Yeah? Can I carry on? Any questions? Please. Higher velocity, lower pressure. Where is this occur? Yes.
Top surface.
Top surface. Okay, good. Top surface. Why top surface?
On top surface.
Okay. Let me go on. Lower velocity, higher pressure. Where is this occurring?
Bottom surface.
Yes. Okay, so to relate to the question I asked earlier, how does it relate? Higher pressure at the bottom, lower pressure at the top. So now there is a difference, right? So because of this difference, you will have this thing called lift. Because of the pressure difference from the top and the bottom, there's a lifting effect. Clear so far?
Yes.
Are you clear?
Yeah.
Okay. So what are the four forces acting? Yeah?
Thrust, drag, weight, and lift.
Okay. Any questions? You seem lost. Any questions? Are you sure? Can you tell me what are the four forces?
Trust, drag, weight, and lift.
Okay. So now we have learned what are the four forces and how, because of the pressure difference, it's causing the lifting effect. Okay? So how is this going to be applied to you in your workplace? Any suggestions? You know what is lift, you know what is weight, you know what is thrust, you know what is drag. All these are limiting forces to your flight. No idea? Okay, let me get on. So when you are going back to your flight, you need to refer to your flight manual to know these limitations of flight. Because as a thrust producing mechanism, your engine has a limit to it. It can only produce that much of thrust. Okay, it's a machine at the end of the day. It cannot produce so much of thrust. Am I right to say so? Right? It's a machine, right? So it definitely has a maximum capacity. Maximum lift is the same thing. Stall angle is what I showed you earlier. So you need to know the stall angle. Why? Because if you happen to hit this and your flight will stop, what will happen if the flight stalls? We will cover that later on. Okay? So now you know your stall angle. You need to refer to the manual to know the stall angle and the stall velocity of the flight. Okay, and importantly is to know the warning mechanism of the flight to recognize which are the areas that will trigger alarms, lights, sensors that gonna inform the pilot or the engineer who's going to troubleshoot the flight. Where is it? What is the error? Where am I missing something? What's going on with the flight? These are the warning mechanisms that I'm talking about. So that when you refer to your flight, you will know that these are something is wrong. Any questions for me?
Is there
Yes.
a maximum number of engines that can be attached to an airplane? Because you say that the maximum thrust, right? There's a maximum thrust that each engine can produce. Right?
Yes.
So, is it like, if that's the case, can I have an infinite amount of engines attached to an airplane, and that would give an infinite amount of thrust, which means that the airplane can be an infinite size?
In theory, yes, but in practicality, no. The reason is because if you're going to do that, you need weight, material, and the runway length. All these are not going to be sufficient enough. As it is, your material is already expensive, which is why we are all being charged for air ticket price. Okay, to cover for all that, for building, for your facilities, and your all the good things that you are being enjoying. Not compared to a budget flight, where in a budget flight you don't get food.
What
But
is-
in, but in SIA you will. Yes.
What was the maximum number of engines you've ever seen on a plane?
4. Oh, that's.
Antonov 225.
I see. Okay.
One of the biggest cargo planes in the world.
I see. Okay. Okay.
Sorry, the biggest cargo plane in the world. One of the biggest aircrafts in the world.
Okay, we can talk about that later. Okay, because I have not seen any. Maybe he has.
I'm really
not
not
sure.
interested.
Maybe because of his age, he may have better experience from it. Maybe. Okay. So for evaluation wise, kindly help me to go into this website to give us feedback on how the lesson was today. Any questions for me? Okay, that's it. That's all we have today. Thank you so much.